Hello, my dear students. Welcome to 9th standard online classes. Before heading into the lecture, let me instruct few points. So first one is about clarification of subjects teaching and about the homeworks are concerned. So you are worried about these points. So I'm trying to give the clarification. So the first point about the clarification of subject teaching. Since we don't have the direct communication, you may under the confusion that which teacher is teaching which subject. So as the days progresses, you will come to know which teacher is taking which subject. So on my side, I can give you the clarification that about the science subject. I am teaching physics subject, so you may call me as your physics teacher. To the second point about the homework is concerned. When I give the homework, then only you follow, otherwise there is no question about the homework. Don't think that I'm not giving the homeworks at all. Okay, my routes are quite different, so you will come to know sooner rather than later. Dear students, let's begin today's lecture by recapping few points on measurement. The act of measuring a quantity required is known as measurement. We already defined measurement in two different ways. Let's try to bring those definitions. The act of measuring a quantity required is known as the measurement, or measurement is a comparison of specified physical quantity with known standard quantity of equivalent nature. Measurement is the comparison of specified physical quantity. Specified physical quantity means you are measuring a quantity of your own, that is taken as specified physical quantity. So you need a chart of doing that. That is nothing but standard quantity. That is the standard physical quantity. The difference between, or the comparison between specified physical quantity with known standard quantity is taken as measurement. We also defined physical quantities. So we defined physical quantities as the quantities which can be defined and measured. The quantities which are defined and measured are known as physical quantities. Length, mass, time, speed, velocity, acceleration, so on. These are all the examples for physical quantities. So you can measure a physical quantity as it is equal to numerical value n into unit u. Therefore, the measurement of a physical quantity, that is equal to q. Q equals to n into u. This is how you are measuring the physical quantity, where numerical value is the number or magnitude and u be the units. We already quoted the example of 5 kilogram mangoes. 5 means that is the numerical value, kg means unit. I hope you understood all these points. With those points, I am moving towards the next point, that is types of physical quantities. The physical quantities, which are grouped into two categories. One is the fundamental physical quantities or fundamental quantities, and other one is derived physical quantities or simply derived quantities. So physical quantities grouped into two. One is fundamental quantities and other one is derived quantities. Students, let's define fundamental quantities. The physical quantities which are independent of any other physical quantities for their measurements. The physical quantities which are independent of any other physical quantities for their measurement is known as fundamental physical quantities or simply fundamental quantities, which means the quantities which are totally independent of other physical quantities. Okay, let's bring some examples here. Length. Okay, if you are taking the length is independent, so you cannot derive anything from length. Length is the fundamental quantity. Similarly, mass is also time, electric current, and so on. These are all fundamental physical quantities. Remember, there are seven fundamental physical quantities. So those things are going to study later part of the topic. I hope you are getting the definition of fundamental quantities clear. Again, the physical quantities which are independent of any other quantities for their measurements. To measure a physical quantity which are totally independent of other physical quantities are taken as fundamental physical quantities. Now, derived quantities or derived physical quantities. The physical quantities which are dependent on fundamental quantities for their measurement are known as derived physical quantities. The physical quantities which are totally dependent on few quantities, those few quantities are nothing but fundamental quantities for their measurement are known as derived physical quantities. So here for some examples for derived physical quantities, speed. So you already learnt about speed in the last year. So we taken speed as it is equal to distance by time. Distance by time is nothing but length by time. Okay. So speed contains length and time respectively. So length and time are nothing but fundamental physical quantities. So you are setting a fundamental quantity in such a way that it must contain fundamental quantity. Those quantities are known as derived physical quantities. So again I am quoting the examples of speed, similarly velocity, acceleration, force, work, energy, power, frequency, etc. All these are derived physical quantities. As I said earlier, fundamental physical quantities are only 7, whereas derived quantities are so many in the subject. I hope you got these two definitions with the examples clear. Now let's try to classify units of physical quantities. We already took the measurement as Q equal to N into U. N means magnitude, U means unit. So we are focusing on that part, that is U, units. The units of physical quantities are classified into two. The units of physical quantities are classified into two, namely fundamental units and derived units. So we already have the two different categories of physical quantities. Those are fundamental physical quantities and derived physical quantities. Similarly, the units of those two are taken as fundamental units and derived units. So let me define fundamental units. The units used to measure the fundamental physical quantities are known as fundamental units. The units used to measure fundamental physical quantities are taken as fundamental units. Example: meter, kilogram, second, ampere, and so on. We already took length as an example of fundamental physical quantity. The unit of length is measured in meter. That is the fundamental unit of length. Similarly, for mass, you have kilogram. For time, you have second. For current, you have ampere, and so on. These are all the fundamental. Again, there are 7 fundamental units, as the fundamental physical quantities are 7. Keep that point into your mind. Now, derived units. The units used to measure the derived physical quantities are known as derived units. The units used to measure derived physical quantities. The quantities which are derived, the units used for that is known as derived units. Meter per second, meter per square second, Newton, joule, watt, etc. See, we took speed as an example or velocity as an example. You measure speed in meter per second. So meter per second is a derived unit of the fundamental physical quantity speed or velocity. Similarly, for acceleration, you have meter per second square. For force, you have Newton. For work or energy, you have joule. Similarly, for power, you have watt. So there are so many groups of derived physical quantities, and hence you have so many number of derived units. I hope you are getting the classification of units right. Dear students, let's move on to the concept of standard unit. Here we must pose a question: why we are taking the standard unit? What is the necessity of taking that concept here? For that, we need to go early days. Say 40-50 years back, the people used to measure the length with the help of various parts of the body. As such, hand span, foot span, arm or cubit or pace like that. The people used to measure the length with the help of various parts of the body itself. So they are using such methods like handspan. The pictures are already given in the screen: handspan, foot, cubit, and pace. Okay, so the people used to measure the length in these methods. Are they accurate? The question rises. For that, you need to go a simple activity here. Consider a boy measuring the length of the table. So assume that a boy is measuring the length of the table using his hand span. So what will be the length of the table? Assume that that is 6 hand span according to that boy. Now bring his father in. Imagine his father is measuring the same table using his hand span. So what will be the length of the table now? It will be around 3 handspan, you may say. Okay, so which one is the correct length of the table? 6 or 3 handspans? Which one is the accurate? We cannot say which one is accurate here. Okay, because father is having obviously larger hands than his kid, so we cannot say that which one is accurate. But the handspans are almost in a systematic way they are measured, but you cannot say which one is accurate. Hence, the handspan or any other type of measurement considered to be not accurate to measure the length. So we need a standard unit that gives the same length when used by anyone. So we need a standard unit that gives the same length when used by anyone, anywhere. The person, for the place. So that length or that unit must be same. That's why there is a necessity of bringing a standard unit in. I hope you are understood this part of the concept. Now let's take the features of standard unit. How the standard units looks like. So there are some features for standard units mentioned. They are standard units well defined. The first point, standard unit should be well defined. Second one, they should be independent of time and place. They should be independent of time and place. Time and place must not disturb our measurement. Okay, that's why they are independent of place and time. They should be independent of physical conditions like temperature, pressure, and humidity. So it must be independent of temperature, pressure, humidity. Those physical conditions must not affect our measurement. So these are the features of standard unit. So standard units must follow these routes. Okay. I hope you are getting all these points correctly. So let's move on to system of units. System of units. As a part of standard unit, I am taking the system of units. The scientists all over the world have developed the basic set of units for measuring various physical quantities known as a system of units. So scientists over the centuries try to develop the basic set of standard units measuring various physical quantities. That system is known as system of units. So this system of units are often called as international system of units or simply SI units. So we take most oftenly this system of units as a international system of units. Before heading into the system of SI units, we study other units still they are in use. So let's try to focus on other system of units before studying system of SI units. So first system will be FPS system. So FPS means what? F means foot, P means pound, S means second. Okay, the system in which length, mass and time are measured by foot, pound and second respectively is known as FPS system of unit. The people still they are using, but for scientific community they are following simply international system of units. But for our understanding we need to introduce these systems. I hope you are following these points. So FPS system means what? The system in which the physical quantities, the fundamental physical quantities, length, mass, time are measured by foot, pound and second system of second respectively. They are said to be FPS system of unit. Second one, that is CGS system. CGS means centimeter, gram, second. The system in which length, mass and time are measured by centimeter, gram and second respectively is said to be as CGS system of unit. Third one, MKS system. M means meter, K means kilogram, S means second system. The system in which the length, mass and time are measured by meter, kilogram and second respectively is known as MKS system of units. In the various parts of the world, people used various measurements according to their own choice. So out of which we collected few here, that is FPS system, CGS system and MKS system respectively. I hope you followed all these systems right. Now fourth one will be the system of SI units. The system in which length, mass and time are measured by meter, kilogram, second respectively. This is similar to MKS system and hence it is called as extended form of MKS system of units. SI units or the system of SI unit in which length, mass and time are measured by meter, kilogram and second respectively. This is the system of SI units. This system was established in the year 1960 and periodically updated since then. Dear students, to understand or to know the importance of international system of units, we need to go for 1999, the story of NASA when they lost a spacecraft due to a metric math mistake which is related with measurement. So that story will be narrated in the next class. Till then, take care of yourselves. Bye bye.